Alright guys, welcome to part 2 of the Gini coefficient calculation video. Welcome to Giniville. So now that we have a Lorenz curve that we found in part 1, so that's what we call that nice curve we just fit, we can use this fit in this curve to find the Gini coefficient, and we're going to do that with integration. So let's take a look at what exactly it is that we're doing. So what we're dealing with here is two distinct curves. The first is the straight line, that's our equality line, and the second is the Lorenz curve, the function of which we just found by fitting the points we found in Google Sheets. So the Gini coefficient is all about a ratio, and in particular it's the ratio of this middle area section to the area of the entire triangle. To find the area of that middle sliver, what we really need to be thinking about is the area under the Lorenz curve, because we'll be able to take the area of the triangle minus the area of the Lorenz curve to find that sort of shaded in middle region there. Once we have that, all we do is take that ratio, shaded middle region over triangle, and that will give us the Gini coefficient. Let's think for a minute about our extremes. What if we did have perfectly equal income? What would our number be? Well, in that case, our curve would shrink up to meet the triangle, and therefore the top number, that sliver, would be 0, and our Gini coefficient would be 0. If, on the other hand, we had perfectly unequal income and no one was making money except for our top 20%, that curve would inflate until it became equal to the triangle, and we would have a Gini coefficient of 1. So what we're looking for is a Gini coefficient that is between 0 and 1. So that is hopefully what we will find. In order to do this, the first thing we're going to find, because it's going to be the easier of the two areas, is the area under our triangle. Now, to find the area under a triangle, it's pretty easy because it is a nice right triangle, and we can just do our area formula. So 1/2 base times height. The base is 1, height also 1, so the area of this triangle is just 0.5. Not too bad. Now the trickier part. We need to find the area under the Lorenz curve. Now, in order to do that, first thing we need is the function, and this is the function we found by fitting our curve in Excel. By fitting that curve, the function that we found is f of x equals 5.73x to the 5th minus 9.35x to the 4th plus 4.99x cubed minus 0.514x squared plus 0.144x. So we can use this equation, and what we're going to want to find is the area under the curve from 0 to 1. So when I set up my integral, it's going to look like that. So the integral from 0 to 1 of that long function I just talked out. Now we have an integral set up, and we need to actually integrate it. Not too bad, and we can use our integration rules to do this. So remember, the power rule says that what we're going to do is take the exponent that we have, add 1, and divide the whole thing by that new number. So x to the 7th, for example, would become x to the 7 plus 1, x to the 8 over 8. So we're just going to do that with each of our components to get an equation that now reads 5.73 over 6, x to the 6th, minus 9.35 over 5, x to the 5th, plus 4.99 over 4x to the 4th, minus 0.514 over 3x cubed, plus 0.144 over 2x squared. Don't forget your plus c, because it's still an integral, and then you put that bar, and we're going to evaluate this from 0 to 1. So now we are all set up in order to evaluate this definite integral. If you guys remember from class that we do that is we take our f of b, subtract our f of a, and that will give us the answer to our integral. So I'm just going to fill in my 1s and 0s for x everywhere in this equation, and you'll find that the second chunk, my f of 0, is just going to be 0. Every term in here is being multiplied by x, so once I have all of my 1s listed out, I can just put a minus 0 plus c, because every other term is going to be equal to 0. My c's will cancel, and I'm just left with this long thing to evaluate. When I do that, I get 0.233. So I just plugged all those numbers into my calculator and evaluated it. I get 0.233, which means I now have the last piece of information I need to find my Gini coefficient. So I now have both my big triangle area, 0.5, and my area under the Lorenz curve, 0.233. So I know that the little sliver area is 0.5 minus 0.233. When I do that, I find that the little sliver area is equal to 0.267, and then I can take that number divide it by 0.5 to get my Gini coefficient, which is 0.534. So I'm all set. That is my Gini coefficient. As expected, it is a number between 0 and 1. It's actually a little bit higher than 0.5, which, spoiler alert, is kind of bad. Giniville is not a very income equitable cities, country, state thing, but we now have the full methodology that we need to find ourselves a Gini coefficient, which for Giniville, again, 0.534. All right, guys, so again, this is a very interesting type of video. I hope you guys enjoyed it. Please let me know if you have any comments about this format or anything like that. And until next time, bye guys.